Okay, I've had a number of questions from students about this particular question, question 12 in exercise 3.1. So looking at part A, what we have is an equation, 5 raised to the power of x plus 2 equals 5 raised to the power of 2x take 1. So the way we're going to start this is to note that the bases are the same. And if that's true, then the powers have to be the same because the two expressions are equal. So I can start by writing x plus 2 equals 2x subtract 1. The entire expression on the left equals the entire expression on the right. If the bases are equal, the powers are equal. Now you just have to think back to year 8 when we solved equations like this. We've got a variable on the left and we've got a variable on the right. So the first thing we do is we remove the variable from one side or the other. So I'm going to just subtract x from both sides. They cross out. That leaves just a 2 there. 2x take 1x is 1x, or just x take 1. And I think at this stage you can just see by inspection that x has to equal 3. And that is the solution. We can check it by saying 5 to the 3 plus 2 equals 5 to the 2 times 3, using the dot for times, take 1. And we have 5 to the 5 equals 5 to the 6 take 1, 5 to the 5. So it does check. And that's our answer. Okay, let's move across to question B. Now this is similar. Once again, the bases are the same. So we've got a base of 3 and a base of 3. The power on the left of the equation is x plus 1, and the power on the right is a 1. We don't write the 1, but it's always there. Okay, stop the video now and see if you can complete this equation on your own. Okay, I'm assuming now that you've had an attempt at it, and you should have again said, because the bases are the same, they're both 3, x plus 1 equals 1, the powers have to be the same, and if that's true, the number that makes that true is x equals 0. And you can probably check this one really quickly. 0 plus 1 equals 1, so it does check. Okay, let's go ahead and try part C. Now this one is a bit more challenging because we've got a base of 2 on the left and we've just got a 1 on the right. So we can't just do what we did in parts A and B. So I'm going to give you a hint, and then I want you to stop the video and try it on your own. So here's the hint. 1 can be written as a power. Anything to the 0 power equals 1, except 0 to the 0. So my suggestion is write that 1 as something to the 0 power. Okay, so stop the video, have a think about it, see if you can solve it on your own. Okay, let's see how you went. Now, once again, this method works only if the bases are the same. So I need to write this with a base of 2. That's like the hint. Now, 2 raised to what power equals 1? Well, anything to the 0 power equals 1. And so that's the magic right there. Basically, we've written the right-hand side with the same base. Therefore, I'll put a therefore sign in this time. Probably should have done that on the previous 2 exercises. 2x plus 4 equals 0. If the bases are the same, the indices have to be the same. And again, solving this equation, I use BEMA in reverse, is my way of solving equations. So the first thing we have to do is add and subtract, then multiply, then indices, and then brackets when you're solving. The first thing I have to do is undo the adding. So I subtract 4 from both sides. They cancel out, and I get 2x equals negative 4. Divide both sides by 2, and negative 4 divide 2 is negative 2, and there's the answer. Okay, quick check. Let's see, we've got 2 raised to the 2 times, using the dot for times. Negative 2 plus 4 equals 1. Multiply first. 2 times negative 2 is negative 4, plus 4 equals 1. 2 to the 0 equals 1, and that, of course, is correct. So the answer is correct. Okay, on to the last one. Okay, again, this is different to the other 3. And once again, I'll give you a hint, and then I'll ask you to stop the video and try it on your own. Once again, order of operations is important with this. So brackets, indices, multiplication and division, addition and subtraction. When you're solving, you undo those in the opposite order. Now, so the brackets are done last, so I'll leave those for now. And I have to undo multiplying by 4. So I divide both sides by 4. They cross out. And 7x plus 7x is, in fact, I'll keep that. I won't simplify that. And let's see, 4 goes into 56. So half of 56 is 28. Half of 28 is 14. So 56 divided 4 is 14. And a couple of students, when they got to this point, said, oh, x must be equal to 1. Because they said 7 plus 7 is 14. So you can just look at it and write the answer. If you didn't see that, then again, 7x plus 7x is 2 times 7 to the power of x, sorry, not 7x, equals 14. Divide both sides by 2, like so, and I get 7 to some power equals 7, and hopefully at this stage you can just say, well, that has to be 1, which is correct. Let's do a quick check. 4, open brackets, 7 to the power of 1, plus 7 to the power of 1 equals 56. This time, order of operations in the normal order, so that's the powers, 7 plus 7, and I'll just do that using the dot for multiply. That's 14, so I'm doing 2 steps in one to save a little bit of time, and 56 equals 56, so it does check. So the answer to that one is x equals 1. Okay, well, these are, again, challenging questions, but interesting questions because they make you think a little bit and show understanding. Thank you.